Hey, Mr. Boer here. Ready for week 5 of 8th grade science online. What we're going to look at today is something new. We haven't been over bonding yet. And there's going to be two types of bonding, ionic bonding and covalent bonding, that we're going to go over. We're going to focus this week on ionic bonding. And then next week, we'll look at covalent bonding. Um, in this, we're going to have to use some knowledge that we learned, both the periodic table and just knowing atoms in general, that we learned from the review sessions. So first of all, bonding, kind of a mess up there as far as a conversion that took place, but no big deal. We'll talk about it. When we look at bonding in general, what atoms are trying to do is to satisfy that octet rule that we talked about. So the first thing you got to be able to do is figure out the number of valence electrons that an atom has. Let's say something like calcium. Calcium has 2 valence electrons because it was in column 2. So you're going to want to gain 6 to get to 8 valence electrons or lose 2. We always pick the lower number. So if it's going to lose 2, it's going to have a +2 charge. Now, when it does that to be happy, call that like we said, the octet rule. It's trying to be like Nobel gases. When it does that, though, that charge, that positive charge, makes it stick to something that's a negative charge. So if we had something like chlorine that had, if you look on your periodic table, it's in group 7A, so it's got 7 valence electrons. Does it want to gain 1 to get to 8 or lose 7? It will always pick the easiest thing to do. It'll gain 1, and if it gains 1 electron, it has a negative charge. So calcium and chlorine would want to stick together. That's the bonding that we're talking about, because of the opposite charges. So when we look at, there's a couple of different types of bonding and ways that it can get to it. It can transfer electrons, like the example I just gave with calcium and chlorine, how it's transferring its electrons to chlorine, and then all of a sudden they have positives and negatives. Or they can eventually share electrons to be happy too. So a couple of things that we focus on, but bonding is just called it's the attractive force that holds atoms together. So that's just bonding in general, and there's a couple different types. What are the types? We're going to look at ionic this week, which is that valence electron transfer that I said. And then covalent, they're going to share those valence electrons to get to 8. They always want to get to 8, and that's the octet rule. And then there is a third type of bonding that we're not going to have time to focus on. That's metallic bonding, and that's basically where a sea of electrons are able to flow back between each one, and that's what gives us the electrical and heat conductivity of metals. So what do we know about this ionic bonding, or what do you really need to know? You must be able to recognize the formula when you see it. In all ionic bonds, how are you going to know it's ionic, covalent, or metallic? Ionic bonds are always a metal bonded with a nonmetal. So it's a cation bonded with an anion. Remember, cation, the T forms the plus sign, and the anion was the negative. That's how we decipher the difference between the two ions that form. But it's always a metal bonded with a nonmetal, and the metal is always written first. So if you want to know if it's a ionic compound, look at the first element. If it's a metal, it's probably going to be ionic. If it starts with a nonmetal, it'll be covalent, that we're going to talk about next week. Now, most of the time, if you look at this sodium, this is salt, sodium chloride. Na is the plus, chlorine's the minus. Here's our sodium's on the left side of that stair step that we talked about last week, so it's a metal. Chlorine's on the right side of it, so it's a nonmetal. But you have a cation being attracted to an anion. You can get some of these that we talk about in chemistry, which will be groups of families that still hold a charge. So this is ammonium. It's a nonmetal, but it's a group that still has a charge. Those are called polyatomic ions. You don't have to worry about those right now. Same with nitrate. It's just a group of elements that still has a negative charge instead of a positive. So the main thing, ionic compounds. It's a metal bonded with a nonmetal. Another way of saying that is a cation bonded with an anion. Either way, positive with a negative. That's the force that holds it together. So a couple of things I want you to know about these ionic compounds is we need to form the ionic substance. So you got to know their charges to figure out what the simplest ratio of atoms is going to be. Sometimes it's real easy. It's K. Notice it's got 1 valence electron. It gets rid of it. So it's a +1. Fluorine has 7. It gains 1. Well, that's a perfect combo. +1, -1. They stick together. What you have to know is all ionic compounds are neutral. So the positives have to equal the negatives.